Tomorrow morning, 3I Atlas reaches its closest approach to Earth, 270 million kilometers, our last chance for detailed observations, and while NASA declares the case closed, it's a comet. Move along. Avi Loeb from Harvard just published new analysis showing the probability of this trajectory being random is less than 2%. The scientific community is divided, not about aliens, about something more fundamental. How certain can we be? I'm Marcel, and today we're looking at the latest data and why this controversy reveals more about science itself than about 3I Atlas. Since 3I Atlas reappeared in the morning sky in early November, we've collected the best data we've ever had from an interstellar object. On December 3rd, ESA pointed their XMM Newton X-ray telescope at 3I Atlas for 20 continuous hours, the longest uninterrupted observation we have of this object. What they saw was soft X-ray emission, exactly as expected. Solar wind hits the coma, ionizes carbon, nitrogen, oxygen. The atoms fall back to lower energy states, emit X-rays. Textbook physics. But here's the interesting part. The intensity of that glow was higher than comparable comets, which means either the coma is denser, or the composition is different, or both. November 26th, the Gemini telescope in Hawaii captures high-resolution images. The comet is glowing green, not the red we saw in July and August, green. Now, green comets aren't new. That comes from diatomic carbon. C2, cyanogen, and cyanide can also glow green. But the switch from red to green within a few months is unusual. The explanation goes like this. As 3I Atlas moves away from the sun, it cools down. Different chemical processes dominate. The reddish tholins on the surface become inactive, while deeper layers with C2 and cyanides remain active. Plausible, but not confirmed. And then came the discovery that made everything more complicated. On December 1st, researchers from ULMA published new data. They'd analyzed the surface temperature distribution of the coma and found point source hotspots, not uniform heating, localized outbursts. The term came up quickly: cryovolcanoes, ice volcanoes. Like on Pluto, on Enceladus, on Triton, areas where pressure builds up beneath the surface until suddenly gas and dust explosively erupt. If that's true, if 3I Atlas isn't outgassing continuously but in bursts, then that explains many of the oddities: the early activity, the changing brightness, the unpredictable trajectory changes. But cryovolcanoes on a comet only 1 to 5 kilometers across? Nobody predicted that. Write in the comments, did you think cryovolcanoes were possible on such a small object? November 30th, Hubble and the JUICE probe on its way to Jupiter photographed 3I Atlas simultaneously. Stereoscopic images from different angles. The result shows the coma is asymmetric. It doesn't point uniformly in all directions. There are preferred outburst regions consistent with the cryovolcano hypothesis. NASA released the images with the comment, fascinating surface activity. We see similar things with long-period comets from the Oort cloud. Avi Loeb published a blog post, or we're seeing controlled outgassing. On December 10th, Avi Loeb, together with his postdoc Carson Ezel, published a preprint on ArXiv titled Bayesian Analysis of Interstellar Object 3I, Atlas Trajectory Alignment, Bayesian Statistics, Probabilities, Loeb's specialty. Back in July, Loeb had already pointed out that 3I Atlas's trajectory aligns remarkably well with the ecliptic planes of Venus, Mars, and Jupiter. Now, the new analysis modeled 100,000 random hyperbolic trajectories through our solar system. Distribution isotropic, as you'd expect from natural interstellar objects. Result: less than 2% of these random trajectories showed as close an alignment with the planetary planes as 3I Atlas. Loeb's conclusion: either we got extremely lucky, or the trajectory isn't random. NASA responded promptly. Tom Statler and a team from JPL researchers published their own analysis on December 12th. Their argument: Loeb selectively chose the parameters. If you don't require alignment with all 3 planetary planes simultaneously, but look at them individually, the probability rises above 15%. And 15% isn't that unusual. With only 3 known interstellar objects, we statistically expect some outliers. Furthermore, the trajectory has changed slightly through outgassing. The original trajectory when 3I Atlas entered the solar system was less aligned. The approach came partly through natural processes. But Loeb had a second argument. The spectral analysis from August and September showed unusually high amounts of nickel and iron. Researchers from the Institute for Astrophysics at the University of Zurich spoke of extreme composition. Loeb asked, if 3I Atlas comes from a more metal-rich star system, older, further inward in the galactic disk, why would a comet there contain so much metal? Comets form in the cold outer regions of planetary systems. They're mainly ice and light elements condense. Metals remain in the inner system where it's hot. His hypothesis, maybe 3I Atlas isn't from a protoplanetary disk. Maybe it's a fragment of something else. A metal-rich asteroid? Possible. Or something artificial. Statler responded in a NASA blog, "We know very little about the composition of comets in other star systems. Our sample is 0. To claim high metal content is impossible is based on a sample of comets from a single star system, ours." He referenced new models of planet formation. If a star is more metal-rich than our Sun, and the thick disk is on average more metal-rich, then differently composed comets form there, with more refractory materials, with metals. The unusual, Statler said, is only unusual compared to what we know. But we know almost nothing. Write in the comments whose argument you find more convincing, Loeb's statistics or Statler's we know too little. This controversy isn't new, it's as old as astronomy itself. 2017, Oumuamua. First interstellar object. Cigar-shaped, extreme rotation, non-gravitational acceleration. Loeb proposed maybe a light sail, extraterrestrial technology. The majority of astronomers said outgassing of hydrogen that's invisible, natural explanation. To this day, unresolved. Oumuamua is too far away for further observations. Carl Sagan said extraordinary claims require extraordinary evidence. Loeb counters that applies in both directions. To claim we know what interstellar objects look like based on 3 observations, that's also extraordinary. He has a point. Scientifically speaking, 3 data points aren't statistics. We can't define a normal distribution. We don't know what's typical. The scientific method normally places the burden of proof on the extraordinary claim. Whoever claims it's an artifact must prove it. Loeb argues, I'm not claiming it's an artifact, I'm saying the data leave it open. Don't rule it out. NASA says we're not ruling it out. But all data are consistent with a comet. Occam's razor, the simplest explanation is the best. But here's the question neither side is asking. What if we're asking the wrong question? For 60 years, we've been searching for extraterrestrial radio signals. Nothing. Maybe we're searching wrong. Maybe advanced civilizations don't communicate via radio. Maybe they don't send intentional signals. Maybe they send probes. Self-replicating probes that traverse the galaxy, collect data, move on. If that's true, if there are millions of such probes out there, then we wouldn't have to recognize them by their technology. We'd have to recognize them by their statistics. Too many interstellar objects whose trajectories aren't isotropically distributed, that preferentially visit star systems with planets, that move differently than natural objects. That's Loeb's real argument. Not that 3I Atlas is definitely artificial, but if we take the question seriously at all, we must systematically search for statistical anomalies. And 3I Atlas shows anomalies. Tom Statler asked in an interview, how many unusual comets does it take before we accept the universe is more diverse than we thought, and not that it's full of alien probes? Good question. Write in the comments if we find 50 interstellar objects in the next 10 years and 5 of them show similar anomalies as 3I Atlas, would that change your opinion? Tomorrow, December 19th, 270 million kilometers away, the following instruments will be pointed at 3I Atlas. Space telescopes Hubble for final high-resolution images, James Webb for infrared spectroscopy of the coma, XMM Newton for additional X-ray observations, ground telescopes Gemini North and South for visible light and polarimetry, ELMA for millimeter radio waves and molecular composition, VLT in Chile for spectroscopy searching for new emission lines. The Virtual Telescope project streams live starting at 5 a.m. Central European Time. Gianluca Massi, who already showed Oumuamua and Borisov live, will attempt to visually capture 3I Atlas. Spoiler, you won't see much. Magnitude 20 plus, a faint point of light, but symbolically important. NASA expects confirmation of existing data. More details about coma composition, perhaps hints about core rotation, possibly direct observation of cryovolcano activity. Loeb hopes for asymmetries in light reflection, unexpected spectral lines, something that doesn't fit the Comet model. Realistically, the data will allow both interpretations. As always, after tomorrow, 3I Atlas moves away. In March 2026, it will cross Jupiter's orbit. But Jupiter is on the other end of its orbit. No close encounter. 2027, it reaches Uranus's orbit. 2028, Neptune. 2029, it crosses Pluto's orbit. Then interstellar space, forever. Exit velocity from the solar system, about 58 kilometers per second. In 8,000 years, it will pierce through the Oort cloud. Somewhere billions of kilometers away, an object from a foreign star system will return to the darkness between the stars, and we'll never know what it really was. The NASA Loeb controversy shows something important about 21st century science. We have incredible instruments, Hubble, Webb, ALMA. We can analyze objects 270 million kilometers away. We can determine their chemical composition, measure their temperature, calculate their trajectory to within meters. But we can't say with certainty whether it's a comet or not, because we have no comparison sample, because we don't know how diverse the universe really is. And that's perhaps the most important lesson from 3i Atlas. Not whether it's a comet or an artifact, but how little we know, how much we still need to learn. The good news is, we'll find more interstellar objects. The Vera Rubin Observatory that came online in 2025 will survey the entire sky every 3 nights. The estimate, 1 to 2 interstellar objects per year. In 10 years, we'll have 20, in 20 years, 50. Then we'll know if 3i Atlas is normal or extraordinary. Tomorrow is the last chance for good observations. What do you hope we'll find? Write it in the comments, and when the data comes in tomorrow, should I make a follow-up video? I'm Marcel from Space Unfiltered. Thanks for watching.